All right, welcome back. We are Game 3001 in the winter 2022, woohoo, 2021 semester. I'll be okay. I'm always thinking about 2022. And 22, it is 2022. What am I thinking? Of course it's 2022. See what's happening with me? I've been completely thrown off by my power problems today. That's what it is. My power problems are a real issue. Yeah, wow, I feel dumb. Anyways, so today what we're going to cover is more stuff about our decision making, and this is pretty cool. So we've got we talked about when we met on Tuesday stuff that's due. So Lab 6, Part 1 and 2 will be due this Sunday. Again, just a reminder that Assignment 3, all things being equal, is due next week on Sunday. So make sure you sign up for your A3 groups. I know some people have sent me mail to remove them from one and put them into the other and all that kind of stuff. Well, we'll see how it goes. So again, let's take a look at some of our things for today, our challenges, and see what we're going to do. So again, to start this lab, you need Lab 6 Part 1 to start off. And this section that we're going with right now, we are section 400. So let's move on that one. So again, moving up online. So let's go to our desktop, and I'll be in the right spot in a second at some point in the future. Wow, it's been one of those days, guys. And completely discombobulated. That's what it is. Here's section 401. And what I'm going to do is I'm going to copy Lab 6 and make it into Lab 7, or Lab 6.1 or 6.2 is what I'm going to do. I'm going to keep Lab 6 of the original one for a reason. And so this would be Lab 6.2. So why am I making this like this and not Lab 6? Because I had some comments last time about, well, what about if I wanted to kind of backtrack and go to the previous version, and what if I want to start over? Well, I'm really having issues today. 6.1. Wow, guys, this is amazing today. All right, there we go. So Lab 6.2. So I'm calling it Lab 6.2, but really it's just Lab 6 Part 2, just so that we know what that is. And I'm doing it differently today because, again, I've had some questions and comments about stuff. So you can always start from the previous lab. I'm going to go to GitHub. We've been having some GitHub issues today. So not only have we been having problems with, for me, for power, but I'm also having really weird GitHub issues. I'm not sure if you guys have experienced the same thing. I know that Alex was reporting that his class is also having issues. Let's do this. We'll say added project files for Lab 6.2, right? We're going to commit to main. That'll make all those changes happen. And hopefully later on, worst case scenario, I'll put these up online. Files are too large. I never got that. Let's see if it works. Yeah, see this? This is really weird, isn't it? You're not logged into your account, and that is really weird. Token instead of using an account password. I wonder if that's what it is. I think like this is what we're experiencing, because I know that we've been using GitHub Desktop, and I'm wondering if that's the issue. So again, guys, I'm so sorry, but I won't be able to push anything right now because GitHub is experiencing issues, and let's see if it's still going. So I'll say GitHub problems, GitHub down, and GitHub will usually kind of give us a status of what's going on. Looks like we're pretty good. It looks like we're pretty good. By the way, earlier it was all yellow, so that was bad. And I'm wondering what the problem is here. So looks like I'm logged in. And the other thing that we can do with GitHub, because section 401, section 400, yeah, so that's really weird. So great thing about GitHub Desktop is it also gives us support to do command line. So we can always go to command line here as well. Let's see if I can do that. Open in command prompt. Sorry, guys. One problem after the other, I always say. So get status, we're on the branch, get fetch. This is the thing that'll do it. It says permission denied, public key, fatal, could not read from remote repository. Please make sure you have the correct access rights. Is that what you guys were experiencing as well? Because that shouldn't be the case. And I'm wondering if it's gitkraken. We didn't use gitkraken. I'm pretty sure we used GitHub Desktop, but let's see if it's gitkraken 401, right? We're 401 right now, right? Oh, we're 400. That's why. Sorry. Let's get back to reality. Back to reality. We're 400. That's what it is. Okay, sorry. See, I'm totally discombobulated. Totally. All right, so that was section 401. Let's go back to section 400. All right, so wow, Tom, it's going to be a wonderful day today. 6.1. Woo, yes. Oh, I love it. Love challenge. Challenge is awesome. All right, and what the heck? What the heck? Oh, that's interesting. Wow. Guys, this is like amazing. Okay, hold on a second. Copy and paste. I know Skynet is taking over for sure. All right, let's make sure everything's in there. Yes, everything is in there. Awesome. Okay, so I'll be okay. Woo! Okay, now let's go back to GitHub Desktop and make sure we're good. GitHub Desktop with section 401, and we are section 400, correct? So GAME3001, section 400. There we go. Okay, so added project files. Woo! For lab 6, part 2. Let's try this finally again. All right, good. And all this to preserve everyone's experience. Okay, good. So there we go. So there's lab 6.2. Awesome. So what I'm going to do is I'm going to launch that lab 6.2. So we're going to keep going. So I'm kind of doing this so that way you guys have a track of which lab we're on. And let's always, like always, let's always check to see how we've been doing from last day. So I always want to recompile and check to see what we got going on. Okay, that's the kind of the main thing that I want to do. So there are a whack of changes that we're going to get to. I also want to, at the same time, go up on content and let's go over to labs. And under labs, Alex has nicely provided us with a lab 6 part 2 steps that we're going to get into right now. So let's go into lab 6 part 2. And the first part is use our thing, and we just made it blank for now. We want to make a new obstacles.txt file that is inside of our assets data folder. We don't have an assets data folder. We're going to create that right now. So that is where we have it. We can pull up our stuff. And the last day we had it like this. And this is okay. We had obstacle 1, 2, 3, but that's not what we want this time around. So hopefully you guys are on the same page with me right now. Let's make a new obstacles.txt inside of our data folder. So again, that's the first thing that is said to do. And there is no data folder. So let's make a new filter. Okay, so again, I'm going to make a new filter, add a new filter. We'll call it data. Okay, there's our data filter. And inside there, I want to add a new item. Add a new item. And notice that I could certainly go with a new item from here, which is our .h file or whatever. And we could do this. It says formatting, utility, code, web, blah, 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 test, graphics. So you can choose whatever you want, and it doesn't really matter as long as you code it the right way. You're totally fine in doing that. So I'm just going to make it a CPP file. Doesn't matter for now. And I'm just going to change the extension. I'm going to browse to where we're supposed to go. So I want to make sure that it's in the right spot. So let's go into the assets source in here and select that. And yep. And then I'm going to change the thing that it's going to be called obstacles.text. And again, we may have to move this somewhere else depending on where this is supposed to go. I'm not sure if Alex created a separate folder or not. We'll check in a second. If we do, we'll move this around. Let's just make sure that it's done. So obstacles.text, there it is. It's a text file. And you can totally do that. It doesn't matter if you want to add it in this way. Let's see what, I just curious to see what Alex did before we move on, because I just don't want to, I don't want to make your experience different than his. I think he actually made it a separate folder. He did. Or actually, we're using the same folder that I had before for background and foreground and all that stuff. Okay, that's fine. So we can move this. So let's what we can do here is I can remove, and when we remove it, let's go into our actual folder structure. So we can do that. We can go to Open Folder in File Explorer. We can go to Assets, and notice that there is a data folder already. And what we're going to do here is we're going to go into our source folder, grab our obstacles that we just made. So if you made it with me, so just cut it out. This is in the operating system. I'm just going to dump it inside of our assets data folder like he said we should do. It's okay. Tom will eventually listen to what's supposed to be done. All right, there we go. So that's where that is. And let's just go into our data folder and add it back in. So we'll add existing item. We'll point to that, the right folder in assets data. We'll pick the obstacles.txt file. There it is. And then we'll click add. And then now it's back. Cool. So that's what our preparation was, that step. And let's put that up on GitHub, because that's a pretty good kind of step that we just took. So let's do that. So GitHub desktop, there it is. And we'll say we added obstacles.txt to data folder. And commit and push. Yay. Awesome. So you guys should be with me at about this point. All right, so next, so that now that we've done that, again, let's go back to our thing. We've taken it up to here. Remove the individual obstacles references from the Playscene. That's no problem. I'm going to do that. So again, in the Playscene, I'm going to go into Playscene.h. And the best way to do this, in my opinion, is just to remove these first from here, right? So this is what we want to do here. And then when we do from here, we can go into our Playscene.cpp and look for those errors. So these are all the errors we get from that. Let's just delete all these. So goodbye obstacles, right? Obstacles, individual obstacles are now gone. No problem. All right, next. What does he want us to do next? So now the next part is that we removed all the obstacles. Modify the old check ship line of sight prototype to check agent line of sight. It also now needs to return a Boolean, which is going to be different than what we had before. All right, so check ship line of sight returns a Boolean now. Well, all right, so first of all, I would do that in the Playscene.h. So in Playscene.h, where check ship line of sight returns void, we're going to make it return a bool. All right, there it is. So that's the first thing. And then, of course, now this becomes a separate function unless we want to go to the Playscene.h and teleport there and just change this to bool. There we go. So it returns a bool. Awesome, but it doesn't return anything right now, right? So, so that's the stuff we need to do. We need to change that. So Playscene.h and check ship line of sight. Check ship line of sight. Good. And get in there. 1 sec. And make sure we're good to go. All right, so a couple things. So returns bool, and we have all this stuff, right? And this is check ship line of sight. Let me just make sure that I'm pretty good to go here, because that's still going to remain. Check ship line of sight is not going to change, right? Because check ship line of sight, we're going to check agent line of sight as well, and it also needs bool. And we're also going to add all other line of sight helper functions to the prototypes. We're going to do that in the H. Okay, so let's do that in the H first. So in the H file, there's also going to be several new check agent line of sights that we're going to use. Okay, so that's one thing that's going to happen. So let's get in there and do that. So again, we'll start with the .h. So check ship line of sight. Okay, that's okay. And it can't be ship line of sight anymore. We're going to rename this thing because it's supposed to return bool. So we're going to rename it to, let's refactor, rename, and we're going to rename this thing to check agent line of sight. So it's not the ship, but it can be used on all agents. Awesome. Okay, there we go. So that's check agent line of sight. We also want to do a couple things, that we're going to do here. So the first thing is we're going to make a bool m underscore check PathNode line of sight. Because remember, this time around we're doing path nodes instead of just agents, and this is going to be PathNode pointer. We're going to kind of put in a path node, and we're also going to have a display object pointer, which is going to be the target object. So this one, check path node line of sight, is between the path node and the target. So that's what check path node line of sight will do. Let's also change the display object from display object to agent. That's something that Alex wanted us to do. Agent line of sight, which is the first part. And the other part that we want is from the agent to the display object pointer, which is going to be the target object. Okay, so that's what he wants us to do. So we're changing these things. I'm going to have to go back and modify check agent line of sight again. Not a problem. And target object is unloved for some reason. Why is that unloved? Display object, target object. Oh, we're using target object twice. This should be agent. Aha. I'll be okay. So we'll take const away for now. We'll get into that. And so this is the new version of check ship line of sight. We're going to get back into that and modify that in a sec. With this, actually, we should probably do that now in the Playscene.cpp. We should call this check agent line of sight, and it should take two parameters now instead of one, an agent pointer as well as a target object, display object pointer. So target object, that's what that is. Let's take away this const for now. So that is what is happening there. And this should be agent, not target object. There we go. So from agent to target object is what we're saying here. All right, so we're adding agent in there, all right? And now, again, we have one little error, which is check agent line of sight. We're just going to, I'm going to leave that error there because I want to go and fix it later. So just to remember. So again, check agent line of sight, check path node line of sight. So that is from the path node to the target. This is from the agent to the targets. This is our ship now. That's what it is. The next one is going to be, let's get the next one's done. M underscore check all nodes, every node, all nodes with target. That's what that was going to be. So again, it's from display object pointer, which we're going to go, we're going to call target object, target object. So that the target object is going to be the thing that we're going to go from all display nodes to the target. The next one is going to be check all nodes with both. So that's both the target and the spaceship. And we also want to have M underscore set path node line of sight distance. So whatever that minimum line of sight distance is going to be, we're going to give it a distance value. Okay. So that so far gets most of them in there. I'm also we're going to add another variable, which is line of sight mode, right? Where 0 is going to represent nodes visible to target, and 1 is going to equal to nodes visible to player. Eventually, we'll come up with an enumeration for this, and 2 is going to be equal to nodes visible to both. Okay, we'll come back to this and modify it later on. So m__ store obstacles, that doesn't make any sense anymore the way it is, because we're going to deal with obstacles differently. We're going to maybe we're going to use a file for this. So we need clear nodes. We're going to get rid of this. And we're also going to have an obstacle buffer as well as another static that we're going to use. Instead of making it static, we'll make it an integer. So take away the static value. And we'll make it another integer that's m__ PathNode line of sight distance. Okay, this is all prep for what we're doing. The rest, so we've talked about a division scheme. We have, let's just check through it. So everything else should remain pretty much the same. Target this will give you a chance to catch up. So target pointer is m__ p target. Spaceship pointer, we got that. And then we're going to look at a obstacle array, but we also want another array. So a standard vector of path nodes, right? Because we want to start keeping track of path nodes. We're going to call this oh, do we have that already? We do have that already. We're just in different order. We have that. I'm just going to put it in the same order that Alex has it, which is this path node vector array, which is right here. Build grid. That is our division scheme that we talked about before for path nodes. There we go. So that is, I think, where everything is the same in terms of the setup that we have as Alex had for his video. And I'm doing this specifically, very specifically, because just in case my internet connection drops, you can always follow the rest of Alex's stuff if you wanted to. Okay, so that, or if you need to. So that's the first part. Now let's kill some of these errors on the second half, right? So again, that was going back to what Alex asked us to do. That's all in the .h. Okay, so that's, so all this stuff here is the stuff we did, okay? We're gonna go and do the Playscene.cpp now. And what he's asked us to do is include fstream because we're going to do some read file functionality, right? So let's put that in there. I think what he did was in the .cpp is the right place for it to go. So again, at the top of the up here. So this is required. It says Frame GUI, and this part here is for us. So this is our stuff. So scene. Required for scene. And underneath here, we're just going to put in that reference, fstream. So this is kind of like built-in stuff. So that we have fstream for the rest of the file. And now we can see that there's several issues that we want to fix. I'm going to start off with these issues first. So the first thing is, in the update function is going to change. And let's talk about how this is going to work. So instead of like check line of sight with the target, we're going to go with not just the target, but from the spaceship to the target. So it's going to be m__ p spaceship to the target. So that's what's going to change there. So that's the first thing, m__ line of sight. And then what we want to do is a switch case. And the switch case is going to target line of sight mode. And line of sight mode right now is a number. It's an integer where 0 is visible to the target, 1 is nodes visible to the player, and 2 is nodes visible to both. Again, we'll keep it like 1, 2, 3, 0, 1, 2, 3 for now. But then we might change it into, if we have time later on. I don't think we will. But if we have time, we'll change it into an enumeration later that's more graphic for us. So case 0, that is between m__ check nodes with the target. That's the one. Check all nodes with the target is going to be m__ p target. We have to pass in the target object. And then case 1 is going to be n__ check all nodes with the with another target, which is going to be m underscore p spaceship. So there's two different targets we can check, right? Because we can use the same function to check nodes with one or the other. That's what we're going to do. And then finally, we can do m underscore check all nodes with both. Okay, so that's the player, that's the target, that's the player, and that's both. So target, spaceship, and then both, just to further highlight those things. Again, not that it makes a big difference here. So that's the first thing. So those are the functions that we're going to use. Let's make sure that those functions exist. We want to make sure those functions exist. We know that check agent line of sight exists, but all the rest of these functions do not exist. So back in the .h file, I'm going to go to Playscene, and I'm going to go here. Oops, I'm going to go here, and I'm going to put in generate definitions by declarations, where I declare these things as well. Let's do that. So finish. So now we have check agent line of sight, and then we have these other ones. Store obstacle, that's going to be gone. That's an error. Let's get rid of that. So we don't need those anymore. So we're going to do it in a different way. And down at the bottom where we have this obstacle buffer, we're going to get rid of that too. So that's not required anymore. All right, so that's what we took care of. So going down the scene from one thing to the next, let's take a look at that from one thing to the next. Let's go into our start. So again, store obstacles, we're not going to do that. No more storing obstacles the same way. I want to be able to read a file. That's what I want to do. And when I read the file, what I want to do is I want to add children right here. So this right in here, just before I'm going to say that my grid is enabled and all that kind of stuff, right? And I'm just going to talk about it, the structure that we're going to use. So we have our ship and we have our target. And before these two things are going to happen, just after the play scene is announced, what the play scene is, we're going to load, create new obstacles, right? From a file. That's what we're going to do here, okay? And then after we do this, we're loading our spaceship and stuff just like before. No change there. And then after that, we will set up the grid, right? And we're going to build the grid and toggle the grid. That's all the same stuff. This is going to be bundled kind of together. And the new stuff that we're doing down here is we're going to set up a few more fields. And one of them is m underscore line of sight mode. We're going to initialize that at 0. Again, this could be future enum, potentially. M underscore obstacle buffer, that's going to start at 0. M underscore PathNode line of sight distance, that's going to be about 1,000 pixels, right? So that makes sense, 1,000 pixels, because people had asked, why can't I see the entire screen? And then finally, M underscore set PathNode line of sight distance, we're going to do that for PathNode line of sight distance. We're going to take that PathNode line of sight distance we just made and set the PathNode line of sight distance to that number. Okay, awesome. So we've gone and done these things. The one thing that's missing is loading from file, and we're going to get there. Okay, so that's what we're going to do. So first, I just wanted to kind of put the stubs in for the start function. We're missing this, so this is a to-do load logic, file load logic, and then that's what needs to be done, and that's going to be blue. So for us to remember what that is. Okay, so let's continue doing what Alex was telling us to do. So, okay, we do remove the obstacle buffer. We set up a switch case. We did that already in the update. You can also comment it out if for now until the line of sight functions are done. We haven't done that. In the start, remove the individual obstacle references. We did that and add the new file stream functionality. Okay, we're going to do that in a second. Also now fill out the obstacle.txt file with data, and it helps to have a data filter to easily find it, which we already did. And then remove the call and function for store obstacles. We did that already. So we just need to add some data to the obstacles. So Alex has provided some mock data for us we can use, and you can modify this data. So in the obstacles, the way the data is going to be formatted, it's going to be X, Y, right? Width, height. Typically is how he does it, right? So X, Y, width, and height. And we're going to have some values. So again, notice that these are going to be different values. So we have one obstacle right there. The second one is going to be at 280. So 80 is the top on the Y, and it'll be only 100, but it'll be 100 wide. So kind of a squarish obstacle, right? That's the next one. And let's copy that again. Copy, paste. And in the next one, it's going to be 480. So a couple of units down. 200 is going to be width, and 100 is going to be height, so a little bit fatter. We can also add other ones. I know that he recommended 5 of them. So where he puts this at a different spot, 180 and maybe 180, and then 50 and 50. So these are the values that he recommends. So we're going to use those values, again, just to stick with what he has come up with. Again, great ideas for what he's done. And then what we want to do is something way more extreme, like 680 across the x-axis and 480 down on the bottom right corner, and 50 by 200, so something like that. So these are the values, and by 200. And what I'm going to do is I'm going to take these values here and copy them. It's not going to help you, but I'm going to put them in the chat so that they're there in the chat, so you don't lose them when I move on. You won't be able to copy them, I guess, for some reason. Doesn't allow you to do copy pasting, but that's where it is right now. Okay. So that's what we're doing. I'm just going to check YouTube to make sure we're good. Looks like we're okay. We've got one watcher. And let's continue to move on all the details, the stuff that we need to do. So that's the part right there. We added this part. I'm going to add the obstacle.text, because one thing that what we want to do is we want to start thinking about how to use the new file stream functionality and what we're going to do. Okay, so I guess this can be put anywhere in a function, and this is really like kind of create obstacles from file. That's what I'm going to call it. So again, it's up to you. This is a little bit of a departure from what Alex did. Hopefully it won't kill our time too much, but let's think about what this is going to do. So again, just like in here, this will be create obstacles from file is what I'm going to call this thing. So not a big deal. And again, it's just going to be a utility function for us to do that. I'm going to put that somewhere, just like we did our build grid, and we have our toggle grid, and we did all these checks, right? So I'm going to do this all just before our obstacle buffer, just at the bottom. We're going to have this new function. It's going to be a void. It's going to be m underscore, create obstacles from file. Yeah, that's what it's going to be done. And let's make that new function. So we're going to generate the new implementation. There it is. And this function is going to basically deserialize the file. So right now, what we've done when we put them into this kind of situation with the obstacles.txt is we've serialized the data. Serialization means we've organized the data so that there's some kind of pattern. So again, X, Y, width, and height is the pattern. All right, so we need to deserialize or read this piece of data in the exact same way. Okay, so that's what we need to do. So let's go back to our CPP file now and get that reading done. So how does that look? Again, a bit of a departure from what Alex did, but still should function okay. So I'm going to use the same code. So again, what we want to do is we're going to use a standard if stream, and we're going to call this the in file. And we're going to open up / assets. Remember, it's on data, and then it's obstacles .txt. So that is going to open the file, right? And when we do that, that in file is, once we've opened that up, what we want to do is we want to say, while that file is open, while not in file is at end of file. If we're not at the end of the file, keep reading is what this is going to do, right? So we're going to say that, let's do a cout, and we're going to say that this is the obstacle that we're reading in, which is the obstacle data. we're going to make a new obstacle, temporary obstacle, which we're going to use called obstacle. And we're going to make that, we're going to allocate memory for that. So there's our new obstacle. We're going to define X, Y, width, and height. And that is the way that the file is organized. Same way the file is organized. Remember we talked about deserialization. That's what we're doing right now. And then what we're going to do is we're going to output, we're going to get from the file stream. That's what it means. From the file stream, we're going to get X, Y, and then width and height. And we're going to read that line from the file stream and basically store those values, X, Y, width, and height, inside of these floating point values right here. So this is deserializing the data. Well, this is reading data from the file. Read data from line in the file, right? And then what we want to do is we want to say our obstacle get transform dot position is equal to a new GLM vec2, where we're going to pass in our X and Y. So that's deserializing the X and Y. And then our obstacle, and then get width, that's going to be, we're going to suggest that it's going to be the width, whatever we loaded in. Actually, this should be a set, not a get. And then we're also going to do an obstacle dot set height, which is the height value. And then finally, we're going to add child the obstacle to the scene. We can do that anywhere. And then m_p obstacles, we're going to push back the new obstacle that we just created. Okay. And after we're done doing that loop, if we've come to the end of file, all we need to do is now in file dot close. Okay. So that kind of, all this does is abstract our create obstacles from file method outside of the start function so that it's just in a separate spot. Maybe we can even use this again at some point in the future. You never know. Probably not. All right, so now let's go back up to our start. So I'm just going to teleport now. I'm going to teleport to the start function, right? So there it is. And inside the start function, just like we said, just where we had that to-do logic that we want to put in, we're going to do that. We're going to say m_ create obstacle from file. And that create obstacles from file is the thing that's going to run when we do that. Okay, so that is that piece. Okay, I'm going to check now with you guys. Are you with me? So we've kind of done a little bit of structuring. Ethan's good. Stanislav's good. Tarif, very good. Okay, and that's not bad. And Shu, okay, very good. Thank you. Thank you for that feedback. All right, so that's nice. Let's see where we are in terms of our structure. So again, we did all this. We filled out the obstacle.text data and removed the call. So we've done all this part. It's time for a commit. Okay, let's do that part next. So again, we're going to say, and there you can see the data that we've added in there, right? And we'll say modified Playscene to include obstacle creation. It's really what we did so far. We've done some other stuff, but that's just the first part we did. And push to the origin remote. Awesome. Next part, what we want to do is in the UI function, we're going to add all the new line of sight functionality. We haven't really deployed what that line of sight functionality is yet. We're going to get to modify that in a second to make sure that it all works. Okay. So first, it's telling us to add the line of sight functionality to the UI function, then fill in the bodies, it's kind of the code blocks for the line of sight functions. I don't mind doing this way. It's perfectly fine with me. One way or the other, we're going to get everything done. So we're just going to go into your UI function at this point. We're going to hop down there. And we're going to start doing some modifications to this. So this is lab 6. Toggle grid stays the same as an example, but then after that, it gets a little crazier. So we're going to leave that separator in place right here. We're going to add another one. And what we're going to do here is there's the other one. And I'm going to say that if I am GUI button, not bullet, button, if IMGUI button is node to line of sight target, right? Then what we want to do is we want to kind of limit the size to about 320. That's what Alex recommends. And that is kind of the pixel size, if I'm not wrong. We don't need a bracket here for that. We've got 320 and this. So what the button does in this particular instance, it says, okay, so this is the name of the button, and the next part is the size of the button. This is a size, so 300 pixels by 20 pixels. Alex is specifying this to kind of make sure that things fit properly. And then what we're going to do is m underscore line of sight mode is going to start off with 0, and that is what it's going to be. So when I click this button, line of sight mode is going to switch to 0. And then we'll do a little bit of a statement. We'll say if m underscore line of sight mode, right, is equal to 0, then IMGUI, same line, and we're going to say IMGUI. This is interesting what Alex has done here. He adds a text label that shows active, right, next to the button that's been clicked. So if this is true, then add an active next to that. That's what that means. Okay. We're going to do this again and again. So let's add a couple more buttons. So we're going to kind of do one of these, separator. Or does he do a separator? No, just this part. And then what he's going to do is let's add another button. So node to line of sight, node to spaceship is the other one. So that's the other option. Remember, node to spaceship. That's again 320. The mode is 1. And if line of sight mode is 1, then IMGUI same line is active. So that's when that happens, right? Again, this probably can be made into a little function, but we're not going to do that here because that's just overkill, in my opinion. All right, so we're just going to grab this. Just a lot of repetition, but who cares? It works. Remember, make it work and then refactor. And then node line of sight to both target and spaceship. Okay, and then this will be number 2. This will be the second, or the 2 option. Okay. All right, so that's pretty cool. After this, he also is going to make a little slider int if IMGUI slider int, and it's going to be PathNode line of sight distance, so we can adjust the line of sight distance, and that'll equal to ampersand m underscore PathNode line of sight distance, right? And we'll give it a distance of starting from 0 and up to 1,000. So that's kind of, you can adjust your PathNode line of sight distance, so you can see how far they can see. And we'll set PathNode line of sight distance to m underscore PathNode line of sight distance, which is what we had before. Awesome. Now there's a separator, then there's ship, and ship, angle, target, that's all the same. The obstacles get generated the exact same way. I'm pretty sure, I'm just checking the code. And then there's the obstacle buffer, that is all the same. And now there's a bit more stuff we're going to do than this. So this is our IMGUI stuff. Okay, so IMGUI is going to look a little different than this. We still can't run everything yet because we haven't got all the other functions in play. And these are the functions here that we need to put into play, these ones right here. Okay, so save. And let's get those functions kind of coded up. This also has to change, check agent line of sight. Also has to change big time from what it is right now to what it's going to be. So let's start with that one. Let's check agent line of sight. Again, it's going to be different than what it was. So up here, we had our spaceship, the one that we're going to check. And let's start off with a basic Boolean. So we're going to say bool has line of sight. Well, that's going to equal to start with false. And we're going to say that whatever the agent is this time, so instead of spaceship, because spaceship is too specific, let's put in agent in here. Agent line of sight, as an example, the default is false. We're just going to type, kind of, instead of putting it in there, we're just going to put that in there. And we can take this default of, imagine the agent doesn't have line of sight by default. That's what we're saying here. Okay. And then the next part is ship to target distance. Let's rename this from agent to target distance. That's a good rename. So again, refactor, renamed to agent to target distance. Agent to target distance. I think that's a good name. Again, we're going to get the edges, and instead of the specific spaceship, we're going to go agent. And we're going to reuse this function over and over again. So agent position to target position, and then agent line of sight. Instead of, if it's less than or equal to the agent, right, get line of sight distance. This is, we are in range if we're there. That's like before. Here's our contact list as before. Well, this is going to be slightly different in here than we had before. We had our path node and so on. So we ignore path nodes here is what we did before. Alex has nicely refactored this one. So we're going to go with a slightly different thing in here altogether. I'm just looking and see the differences that he's got in here. Quite a few differences, but he's kind of compressed it. Let's just rewrite some of this. So so this is gone. He doesn't do this anymore. And then what we're going to say is he's actually got something else in there. So we're going to say auto agent to object distance. And let's just rename the one that we already have. So we have agent to target distance and agent to object distance. Let's rename this one here. So so refactor, rename agent to object distance. So if agent to object distance is, and he's kind of changes around. So that's why he took that other check away. So this is if it's greater than agent to target distance, right? That's what he's got in there. Then what we want to do is continue. All right, so we want to continue. And this part is the part that we want to change. And then he's got this other piece in here where the stuff we did before. I'm gonna redo this. Just give me 1 second. So this part he's got down in here. So display object type, get type. Instead of not equal to spaceship, it's going to be not equal to agent, right? So this will be not equal to agent itself. This is the type. So get type is not equal to agent. And we're going to move this in here in a second. But we're just going to keep some of the structure. So we called ours display object. That's fine. Display object. Get type is not equal to PathNode. That's what this is. So that's what he's done there, PathNode. And he's also got a third check now where display object get type is not equal to target. So one of those two. Let me explain those in a second for you after we refactor. There it is. So that is that piece, and that piece, that whole if statement chain, this part right here, it shouldn't go here. It should actually go just above this contact list right here. So this is where that goes. And then we don't need this part, and we don't need that part. And we can kind of bring this in a little bit. Yep, we can bring this in, and we can kind of get rid of a couple lines. I'm going to explain what he did. So he's refactored it, so he's doing the exact same thing as last time. This should be agent. But what he's done is he's reduced some of the code and to make it a little bit more effective. So these two if statements, what we had before was okay, but now what he's done is he's optimized some of the checks, display objects. So this part is okay. So this is the new piece of code that he's got here. Okay, hopefully you guys can see that. Agent, path node, target. Okay, so where display object is going to be checked with all of them. All right, nice. So that's excellent. Now, what about the next part? So we've done this part, and then there's a const auto has line of sight, is what we called it last time. Well, this is also going to change pretty drastically. You know, theoretically, I should have probably rewritten this whole thing, but it's okay because we're going to just move on from here. Yeah, we're just going to get rid of this and just start it over. There's too many changes. So again, we're still in the if statement, big if statement on the top, where it's agent to target distance is less than or equal to the agent to get line of sight distance. That is still, we're in there. We've just finished doing the for loop. This is the new for loop that we're using, right? And then after the for loop, after we've refactored, we're going to do a const glm vec2, where the glm vec2 is going to be called agent endpoint, and that's going to equal to an agent get transform dot position plus my agent, and we've seen this before, get current direction, and then multiplied by agent get line of sight distance, which is going to give us the line that we're going to draw from one to the other. We're going to say that has line of sight now, because we're going to use that new variable that we've created up above. Has line of sight is, we're going to say, hey, collision manager, let's do a line of sight check, right, between the agent endpoint and the contact list, as well as the target object. Okay, so that's kind of what's going on in there. So line of sight check is happening with, okay, if you notice what this is, it says from the agent to the endpoint, agent to the endpoint, and then we have a the display object array objects, and then we're going to have to the target. So this checks all the entire contact list with the target object, and this is the overloaded check that Alex wrote. And the last bit is we want to modify the color, right, that we're going to put in here. And we're going to do that right in here. So we're going to say if our target object, right, get type is equal to agent, if it's equal to agent, then what we want is our line of sight color. Actually, we can probably write this a little differently. We're going to say that line of sight color, this is mine anyway, line of sight color, right, is what we want to set up. And I think what I'm going to do is up here at the top, let's do this. We'll say that GLM, we'll establish a new vec4. We'll call that line of sight color, okay? Line of sight color. And we'll say that line of sight color is equal to, let's check if the target object is an agent. If it's true that they are an agent, then what we want to say is that the line of sight color is equal to a GLM vec4 object, which is 0, 0, and 1. Okay, so that's RGB. So if it's an agent, the path nodes are going to be blue, right? Otherwise, if it's not an agent, the color is going to be green. So again, we're going to take this value and we're going to put it in there, and this will be RGB. We'll just change the values around. So it's green. Again, if it's anything else, otherwise it's blue. And this is for the line of sight color check, okay? And then we can do this in one line, and we can just get rid of this. And we can say that the agent set has line of sight to has line of sight with a line of sight color. And we need an overload for this because we don't have that capability for set has line of sight. So here's where, again, slight departure. But before I move out of here, I'm going to fix this. But we want to go to return has line of sight here. Okay, that's what we're going to do here. Return has line of sight. But here, set has line of sight cannot take a bool and a color. It only takes a bool. Let's go into the agent superclass and modify this. So go to definition. And you can see that it only has one overload. Set has line of sight. We need to make another one in the agent.h file. So again, I'm going to go into the core agent.h, and right now we have a set has line of sight that only takes a bool. And we're going to write another overload, set line of sight, which takes a bool, as well as a vec4, glm vec4, which we're going to call a color. That's the new function we're going to write, and that's inside of the agent.h, right? Agent.h, because I'm adding another overload for us, so we can add in a color. We can specify a color to set has line of sight. All right, I'm just going to make it neat. So now what I want to do is I want to generate implementation, which is this, and it's going to be the exact same as this. Okay, so again, there's other ways to do this, obviously, but instead of passing in whatever the color value is, so this is our RGB, right, and this is red. I want to pass in this value here that's going to sit here. So what it's saying is basically if the agent has line of sight and I pass in a color, right, then, and again, I could have rewritten this function. I just want to make it backwards compatible with other code reviews. That's why I've done this. But basically what it's saying is, hey, let's make a state, whatever the state is, pass it in. And if I specify a color, then I'm going to use this version of the function, not this one, where I pass in the color in here instead of this generic color of green. Okay, that's what it does. So here we can make these const. So again, we can clean some of this up later on. There we go. These are const. And now if I go back to, let's update this one. So all I've done here is I've added a new overloaded function, set has line of sight. I'm just going to copy this. I'm going to post this here inside of your chat. And in this set has line of sight function, what it's going to do is going to allow us to add a color change to our to the nodes, depending on if I'm targeting the ship. Okay, so instead of blue, instead of always being green, we can make it blue. All right, so that is this piece, and we can close these off now. And what I can do is I can go back here, and now you can see line of sight color. It'll accept that. Awesome. All right, so that we've just modified our check agent line of sight. I'm going to put that up on GitHub, an extra commit. So I'm going to say here, I'll say modified check agent line of sight, or we'll say instead of modify, yeah, we did that. Okay, which is what we kind of did, and then push that to origin. All right, so that is the big change. So the big change makes it from a ship specific to a ship, and now we can put any agent in there we want, which is really beautiful, right? And the reason why is because this gives us the flexibility to check line of sight with any object that we want, as opposed to just one, which before was just a ship. Okay, so now we can reuse that. That's a core kind of point. What we want now is we want to be able to start checking these other nodes, right? So first we'll start up with check path node line of sight. And in check path node line of sight, this is where some of these changes are going to go in place. I just want to make sure that we're good to go. Yes. Okay, so here are the changes that are going to be in place. Okay, so let's do this first. So I'm going to check angle to the target so we can still use line of sight distance for path nodes. And the way it's going to be is auto target direction. It's not going to like that. Or we'll change that, is equal to the target object get transform dot position minus, so this is the direction, minus the path node get transform dot position. Okay, so that's the direction from the again from the path the target to the path node. This is going to point. It's going to be a big vector. So again, what we're doing here is we're drawing a line from the target to the path node. All right. And once we've done that, we can we'll say normalized direction. We've done this before. Is we're going to use the util normalize function where we pass in the target direction, right? So this gives us the big vector with and the big vector is going to be with a magnitude from one position to the other. But we don't need the entire magnitude or the length. All we need is a length of 1, which is what normalize does for us. Once we have that, we have the ability to say that the path node set current direction. We can use that normalized direction to set it. So we now are pointing in the right direction. And then we can return m underscore, here we go again, check agent line of sight distance between the path node and the target object. Okay, so that's what this is doing. So notice that we used agent check line of sight, this big one we just wrote, but we're using it or rewrote. We're using it for check path node line of sight distance, which goes from the path node to the target. So that path node to target stuff is good. And the next one is check all nodes with target. All nodes with target. So again, we're going to say for each, we're going to run a for each loop where we're going to look at the grid of tiles. Where we're going to look at the grid of tiles. I love Visual Studio. I love Visual Studio. And then we're going to say for every path node in the grid, we're going to m underscore check path node line of sight between the path node that we're specifying and the target object. So again, things to note is check all nodes with target uses this function in here. So we can write it separately, and it's just going to call that check path node line of sight right here. Awesome. Okay, check all nodes with both, right? Check all nodes with both. What this does is, again, we're going to do a for each, and it's going to go for m underscore p grid, and we're going to say for this path node, for each, I'm putting it in the wrong spot. Hold on a second, I'll fix it. For each path node, let's put this one over here. I'll be okay. For every path node in the grid, right, then we want to m underscore check path node line of sight distance between the path node and the target object, whatever the target object is. And did I mess this up? Check all with both. No, I did actually not mess it up yet. I was gonna mess it up because I already did this path right here. What it should look like is bool line of sight with spaceship, right? The Boolean is going to say that, okay, cool. Check path node line of sight with our path node and m underscore p spaceship. Hey, and we're also going to check line of sight with target, right? Which is going to be m underscore check path node line of sight with path node and m underscore p target. There we go. So that kind of does just the target, all nodes with the target. This goes all nodes with the spaceship and all nodes with the target together. And what we're going to do is we're going to say path node set has line of sight, and it has to be with both. So it's going to be if I have line of sight with my spaceship at the same time that I have line of sight with the target, if that's true, right, then I'm going to return true. Otherwise, I'm going to return false. Okay, so if these two are true, then this is true. Actually, this is kind of redundant. We probably can just do this by itself because this will be either true or false. If both are true, then it's going to return true, which means we don't have to really do this, but it's okay. All right, so that is check all nodes with both. And the last one is the function where we want to set path node line of sight distance, which is something we want to do, right? So set path node line of sight distance. It's pretty simple. We're going to do that for each loop again. I'm just going to grab this one this time around because it's less complicated. So for every path node in the grid, what we want to do is we want to say that, hey, path node, I want to set line of sight distance to whatever the distance is. We're just going to convert it to a float. Yeah, there we go. And this should be, let's just do some corrections here. So this should be a const. This should be, it's going to probably like static cast. Yep. So that's what this is going to be. And let's just go through and check some of our code for everything else. Don't worry, I'm going to be there in a second. I'm just going to go back and show you everything again. So check all nodes with target, check all nodes with both, check all line of sight distance. Okay, and the things that are underlined in green while I'm pausing for a second, right? Sorry, Christian, is most likely it doesn't like it because it's going to say, it's going to suggest this one, rename line of sight with Spaceship. I mean, I don't know. I'm probably fine with this. And same thing with this. I'm not really finicky on these names right now. But what it kind of breaks some of our conventions we've been using before. That's all it is. Can I move on now, Christian? Or you want me to go back to something else? You're good. Okay, excellent. So back up here with target direction, right? So again, this is another one that it's saying that, hey, target direction is equal to this. I'm not so, I like these ones because it's line of sight with Spaceship, line of sight with target, but I don't know, maybe these ones we can change. First of all, there should be const, and because it's not changing, and it's asking us to change the name, right? That's what it's going to do. Here, same thing. We're probably going to add a const there because it's asking us to change that. And then what it's probably going to ask us is, well, you probably should name this normalized direction. And you probably should name this to target direction. I'm okay with these names, the new names. It's going to take away these. I don't want to see any green lines anywhere. So all I'm doing is refactoring here. All right. Let's kind of skim up to some of this. Display object get type. And it says, if I hover over here, it says negative expression. It's asking us to remove this and flip it around, negate it. I'm not going to do that. Line of sight color could be something else, but I like line of sight in color. So I'm not going to change that. Has line of sight could probably change, where they want us to put has underscore line of sight. It's so small. I'm okay with changing that. It'll change it everywhere. So again, I'm just going to go with resharper's changes for some of them. Has line of sight. But you know what? Let's undo that because it should be. All right, there we go. Sorry about that, guys. My NVIDIA broadcast just crapped out. That's what it was. If that makes any sense to you. What is going on here? All right, let's run this thing and see what happens here. I'm just going to see if we get any errors, and if we do, then we'll correct them before we push this up on GitHub, because I think we're mostly done at this point. Good. So it read nicely. Take a look. It read nicely from the file. This is nice. And then we have our grid. We can toggle the grid on. Notice that by default, it's node line of sight to target. So these ones here in red do not have line of sight to the target. And the way to prove that is if we draw some lines, we'll use the annotator to do that. So I'll draw some arrows. Okay, so let's see. So do I have line of sight from this one, from the middle of this node to the target? And notice that it goes from the middle to the middle. And the answer is no, right? Take a look at that. It crosses right in there. How about this one? Does this have line of sight from this one here? These are the closest ones, right? From this one to this one. And because we cross, this line goes right through this part right here. These are imaginary lines that get drawn, right, as an example. Then that's why these two nodes are null. And the same thing goes with this one, because this is kind of in line with this one. No. This one's no. Take a look at that. So this is just to the middle, just barely touching. And same thing, this is clearly, there's no line of sight here. And I'm just looking at the ones that might have line of sight, like this one. Let's see, this one looks like it has line of sight. Let's see if it's true. And no, because it kind of skims this part right here. So see what's happening? So each of the nodes now is kind of going and, you know, kind of trying to see if there's line of sight. And they're both going through these obstacles. That's what's happening here. Okay, so that's why all these nodes are red. Okay. Make sense? Yours is mega broken. We're going to fix that in a second. Because I'm going to push this up on GitHub and you're going to compare my code with your code. All right, so what about if I go node line of sight to Spaceship, right? So if I click onto this, then now you can see that if all the nodes that are blue have line of sight with the Spaceship. So again, it'd be the same thing, but all the ones that are red over here do not. So let's see if we can do the same drawing that we did where the red nodes cannot see the Spaceship this time. So how does this work? Then if I take this node right here, it looks like it has line of sight. Let's see, it does it. And the answer is no, because it goes right through there. You can see that the same stuff is the case where these ones don't have line of sight. This one looks like it has line of sight, but it doesn't because it just touches the edge. Look at that, right? And so on. So it's the same idea with line of sight from these nodes to the Spaceship. Awesome. And what we did was, just like what we talked about in class, if I click this one, then it's going to be node line of sight to both the target and the Spaceship. So if I click on this one, you can see now, what happened to that one? I think we need to modify this color. We're going to come back here and modify this color in a second. So it's actually blue, or a bluish color, light blue. I think I missed that part. And that's okay, because we're going to fix that. But notice these green nodes for now are for both the Spaceship and the target. And all the reds are the places where it's either the target or the Spaceship is ugly. Okay. All right, one other thing you can do is you can change the obstacle buffer. So this still works. So you should be able to change the obstacle buffer. You should also be able to change the obstacle position in real time. And it also changes the line of sight for the obstacles as we redraw the grid. That's what's happening here. So if I move this obstacle to the back, you can see that I have perfect line of sight now to all these obstacles there. We should be able to change anything that's on the screen around so that they can accomplish that situation. All right, awesome. So let's push this up on GitHub. We need a couple of more changes before we stop. I wonder what that is. It's not that I can access it or anything. All right, let's put a GitHub desktop. There we go. Here's GitHub desktop. And what I want to say is we added or completed line of sight functions. Completed line of sight functions. All right, and commit to main. And push. So where was that line that I put in? I had put in another line. May have missed it, but is it checking for line of sight to the middle of the target or just a distance rect? Oh, it's actually the edge. It's from edge to edge is what it is. That's what it is, Tarif. I'll come back to that in a second. Let me just fix my my color. RGB. Oh, I see what I did. So yeah, so let's go back to that one. So that is where I did the line of sight with Spaceship and line of sight with target, that one. And that's down in here. And where we say we need both target and set has line of sight with spaceship and target. Well, yes, this is nice, but what we can do is, remember we added our little function so that we can actually not just take one value, but also take in a second value. So we can say, let's just encapsulate, let's encapsulate this whole thing here. And then we'll say that this part is GLM vec4. There it is. This is the stuff we're missing, where we say that 8 will be a turquoise color. This is the turquoise color right here. RGB is turned on, R is turned off, and this is turned on. We can also get away with just putting this part in, but without this little check. And why? Because if you think about it, if I check, if it's line of sight with spaceship and with target, right, that's a check. That is a condition. So if these two both are true, then this returns true. Otherwise, it returns false because it's true. So let's see if that works. This is kind of a streamlined version for me. And let's see if that works. And then we'll come back to that. So let's run it, and maybe it's not going to work. Maybe. All right. So toggle grid, and I'm going to choose this one this time, and it should be that weird turquoise color. Take a look at that. So this is where both things. This is where both read this. This turquoise color is both they have line of sight to both the target and the spaceship, and you can draw lines to this. So if I was going to draw that, let's draw a pointer. So this one here, right, should have line of sight to the spaceship, and it should have line of sight to the target at the same time. See that? So now this is interesting, right? One of the to-dos that you have is, can you draw this line? Can you draw a line from the ship to the nearest node that has line of sight with the target? So this is not the nearest. How about this one? There's the nearest, right? That's the nearest one that I can see. I don't think this is the nearest. So this would be the nearest one. And you want to draw from here to here. This is your to-do. And then from here, you can go right to there. And you can see that that is the path that you would take from here to here and from here to there. And that's the path to the target, okay? Now, from what I understand from Alex, what he wanted to do is make this something that you did dynamically. So that means if I had a control, or maybe a button that I would click, if I clicked on the button that said, find the line of sight distance, that's one thing. One thing I also want to check is the ship itself, does it have line of sight? Right now it says no. You can see that that's clearly not the case, doesn't have line of sight. And also, notice how the grid, it's going above or on top of the target, and same thing with the spaceship. We can change these two things, by changing the layering of this stuff the way we want it to be. All right, so that's something to note as well. We haven't done that yet, but we can. So notice how these things are above it, but we should be below it. So let's move this ship right now. So we can say that here's the ship, and I want to move it down on the y-axis. So I want to move this down. Once I move the ship down, then it recalculates. The nodes will start recalculating to see which ones have line of sight with both, because that's what I'm on right now. It has to be both the ship and the target. Okay, and then let's move it kind of closer. And then let's rotate the ship so it touches, and you can see that it goes green, right? Because when I'm kind of intersecting with the ship to the target, then that is green. I can turn the toggle off so you can see it a little better. All right, so let's make that change so that the target is going to appear at a higher level above the nodes. How can that be? Well, remember, it's order of addition, typically how it works, the painter's algorithm. Can you click on the line of sight target button for a second? 1 sec. Line of sight target. Which button would that be? This one or this one? This one. Okay. So I can move back and forth from one of these, right? That's how it goes. Is that what yours does? The nodes on the far right, these ones here don't turn, or down here maybe? Are these ones don't turn green, or up here at the top? Well, that's weird. And this is for node to line of sight to the target? That's weird. Those should work for you. Yeah, and also the other thing is the distance. Path distance, if this isn't 1,000, then the top nodes may be up. Let's say if I reduce these numbers, let's say if I change these, right? And if I change this right down, notice that the line of sight goes down like this, right? Because if the nodes have very small line of sight, it's almost like how far can the nodes, each node see? If I say they can only see about 100, then they can only, there's only these nodes can see the target, as an example. And if I said line of sight to the spaceship from those, you can see only these nodes can see the spaceship, right? These ones, these blue nodes, because I've reduced the path node line of sight distance to something smaller. If I click both, everything is red because that is really small, right? It has to be quite big. So if I start increasing that number, you can see that there's a few nodes here and a few nodes there that have line of sight to both. Okay, and again, I can also reduce that number, right, by increasing the obstacle buffer as I go, right? So if I increase the obstacle buffer out, you know, as an example, then more, you know, it kind of loses that. That's weird that it did that too. Let me see that. Yeah, that's weird. That's really strange. That was a 0, 299. Let's move that down again. Let's go back to 299. Isn't that weird? That's a glitch. They work if I change the distance to 500, but anything higher, it stopped working. Huh, interesting. Christian says, I had to click the path node line of sight distance slider for it to actually update to 1,000. Yeah, that's something that's weird. So it looks like the line of sight distance, this part right here, right? There's 1,000 right there, right? Let's redo that. Let's see if we can find that bug, because that's a bug in our code. So so the path line of sight distance, yeah, there's 1,000. Just curious. And then if I change if I start making the buffer bigger, it reduces some of that noise. And if I click both, then this has both this thing and that thing. Huh. And if I reduce the line of sight distance, it starts reducing the numbers down. Yeah, it looked weird for a second. It looked like maybe it's an order that we're doing it. Yeah, there's definitely a bug. Again, but the idea here is the same, and Alex and I will work out the bugs. I think that we're going to do that together. Maybe I did something different than he did. But anyways, the idea is the same, right? Let's, what was I going to change? Oh, yeah. So let me go and review this with you. So what he said is, well, first of all, I got to do this with you. So the line of sight function from the collision manager from last week. So the line of sight function from the collision manager, I'll look at that right now. So let's get that out of the way. Talk about that first. And that's interesting, right? Because if we go to the collision manager, so that's under managers, collision manager.h. So what Alex has done is he's got a couple of things happening, right? So we've got a line rect edge check. All right, this is a line rect edge check. So from the line to the edge of the rectangle, right? And then he's created a line of sight check, and the line of sight check goes from the agent to the endpoint. This thing here, this is what he made last time. Let's take a look at that. Go to definition. And yeah. So the way this works is you get the agent, the endpoint. This could be const. There we go. The agent, the endpoint, a display object. A list of display objects. So this is the contact list right here, and what you're checking against from the agent to the target. And what you're doing is, if there's any display objects in the middle, then what ends up happening is then you don't have line of sight. So this is the way it would work. So first you say the start point is equal to the position, right? And the end point is what we gave it. For every object in the contact list, that's what this is here, for every object in the contact list, then we're going to create we're going to keep that object offset, where the object offset basically goes to the middle of the object. That's what it does, right? And we're going to say, we're going to do a line rect check between the start and end point. So this is the start and end. This is the line, right? And this is the distance, because if you notice, line rect check goes from the line start to line end, and then that's the first line. And then from line start, rect width, rect height. So this is the rectangle. This is the third and fourth parameter is the rectangle itself. So start and end, the start of the rectangle, which is this part right here, object, which is the current object, position minus the object offset, so the middle of the object, and then the width and the height of that object. And if this is true, then it's false. And the reason why it's returning false is because if I can connect with another object, if I can make a line that goes from the start point, right, which is the agent origin, right, to the end point, and there's an object before I get to the target, then I don't have a line of sight. That's what it does. It returns false right away. So it kind of exits from that little thing. So it doesn't have to check every object. If one object blocks line of sight, then all objects block line of sight. That's how it's looking at all objects that are in that line. Okay. So example would be, if I was going to talk about it more graphically, let's draw it. So imagine I have 2 points, right? So I have a node, this is a node, and then I have and this is my spaceship. And let's suppose this down here is the target, and then I have some kind of obstacles in the middle, right? And what I'm doing is I'm drawing line of sight lines from the player, let's say, or the spaceship, to the target. And let's suppose there's another one. Okay, so I don't just have this, but I have another one over here, right? So both of these two things are on the contact list, but this is not, okay? Because these ones here are intersecting with this line, because this line goes, okay, so I've got a contact list of objects, 1, 2, and I might have another one. This one might also be in the contact list. Maybe the target is way up here, right? So I have this line that's drawn. If these two things are in front of the target, then I have no line of sight, right? And it makes sense that I don't, because this one would block line of sight, right, to the target. So if I check 1, I stop at the first one and return false, right? I return false because guess what? This one is already blocking. I don't have to check this one anymore. That's what this does. And remember, we're passing in the contact list from what we're doing. So that's from our previous functions. I guess that's how it works. And the next part is, okay, so auto target offset again, just like we kind of did before. And so target offset and object offset. So this is the object and this is the target. So, okay, so let's do a line rect check from the start point, again, the point, to the end point. So wherever that's going, from the ship to the target, again, as an example. And then we're drawing so it's kind of the same line rect check right here, where if this line rect check is true, now if we're hitting the target itself is true. So if I'm still hitting the target, if I've passed this check, right, this checks all the obstacles inside of the obstacle list. And then, okay, fine, we checked through this, it's not intersecting with any obstacle. Well, now I want to check to see if I can still see the target. Because what if my line of sight line is too short? So example would be, let's suppose this here is my obstacle, which is square, right? And this would be at 80, this would be at 3. So notice that we have nothing blocking between the ship and the target, but the line of sight line is still red because it's this line, even though it's going towards the target in the direction of the target, is not touching the target unless I move my ship closer. That's what that line does. If I move my ship closer, right, and if I just touch the target, it becomes green, that line. And that's why you have, that check right here inside of on the second check. You're doing this check twice, one for each of the objects and one from the target, from the ship to the target in this case. So that is that line of sight check that Alex wrote. Pretty cool. I like it, and it allows us to run from one from any node or any path node to the target, or any path node to the spaceship, or to both. Okay. So that is the collision manager check that we had. Now, one thing else that I want to do before we go is inside of the start method. Let's take a look at that start method for a second. So here's something to note, right? We're adding in the obstacles first. Okay, we're adding in the obstacles first. And once we add in the obstacles, right, when we create the obstacles from file, we're doing it in painter's order. So typically what we're going to do is we add the obstacles, and then afterwards we add the ship and the target. Okay, so when we add the obstacles should go in, last. But things to note: that reading a file is, can kind of get us a different layering order, right? Because, so example, if I was to put this create obstacle list from file down here, then what's going to happen is that all of these obstacle, the nodes, the obstacles are going to appear, as an example, below the target and the spaceship. This is going to appear. This is going to appear below them. This is going to appear above them. Let me show you. So if I move this from here, this is the obstacle order, to here. Here's the obstacle order, right? So if I did it this way, and if I ran the same file, remember it's in order of how we've added it to the display list, right? It's in layer order. And if I was to pull this out again and toggle the grid, and let's suppose I move the spaceship over there, take a look. Now the spaceship goes kind of underneath the target, right? Where the target actually appears above the spaceship, right? Or the obstacle, I mean. The obstacle appears above the spaceship. So, but what if I did that, if I moved it back, just to give you a sense of how this is layered, right? If I move it back in the start function, then if I did the same thing, now the spaceship is above the obstacle, all right? And the reason for this is because the obstacle goes in layer 0. This is layer 1, like to give you an idea. This is layer 2. And then when I build the grid, this is layer 3. So layer 3, when the grid is built, it's built on top of, right, everything else. This is a higher level than everything else is being built, okay? So how can we do this? What if I build the grid somewhere else? Is that possible? And how could that possibly break our code? Well, does the build grid function depend on anything else from being done? So let's take a look at that build grid function for a second. Go to definition. And we can see that the build grid function, one thing that we have to think about is, does it care? Does any of this, do we care about anything in here? Well, we do. We care about obstacles being loaded first. So the obstacles definitely have to be in place and loaded before we build the grid. So that is a must. Okay, so obstacles have to be in place for sure. Okay, and that's okay because the way that it's layered right now, it's okay. But how about the target, right, as an example, or the ship? And there's nothing in here that has anything to do with the target or the ship, right? We do toggle grid, so that is something that we need to do. But at the end of the day, there's nothing else. Let's see if we can move this around to see. Let's go back to the start scene again. So we need the obstacles to be created first, but then what we can do is we can take this whole piece, right? And again, probably all of this, right, is what I'm probably going to move. All of this first. Let's see if we can move all this so that the target and the spaceship is at the bottom of the start, right? So grab all this and put this in there. Remember, if it breaks, we can always move it back. That's the beautiful thing about trying this out, right? So let's put this in there. Save. Again, just a little slightly different order, and let's see how that looks. Yes, I can. So then if I do it this way now, you can see that the spaceship is on top of the target is on top of the grid, and the grid lies beneath the target, and it's beneath the spaceship. So example, if I move the spaceship to the left, you can see that it obscures the node, right? It obscures the node. And same thing goes with our target. If I move the target, the target obscures the node, all right? But we don't care about this because if the node, any of the nodes are connecting with or touching with these the obstacles, then what ends up happening is they'll be removed. Okay, that's what will happen. They'll be removed. All right, so that's good. Now, sorry, Ethan, you wanted to see the node line of sight to target after? Node line of sight. So do you still need to see that, or are you good, Ethan? Okay, good. Excellent. So that is this part. And I'm just going to check to see if there's any other issues that we can kind of glimpse. So he did it that way. Yeah, so that's the only thing. The only thing I changed was the order that's in the start scene. So the start scene should have the ship and the target last, and then it should have the create from file first, followed by building the grid, because we need to know about the stuff in the obstacles that have been added into the scene in order for us to do this part. Okay, how about this part? You guys said that it won't actually see the 1,000 line of sight distance without it being clicked on. Okay. So that is an IMGUI issue. Let's go to the IMGUI function. Let's see if we can get there. And let's see what we can think of if that's an issue. So toggle grid, not a big issue. All right, line of sight mode is 0 if we click on the button, and that stuff works. And then we get to this slider in thing. Okay. So notice that PathNode line of sight distance, right? If we were going to read PathNode line of sight distance from here, and it says set the PathNode line of sight distance to this, the only time this is set, as an example, the only time this is set is if I've changed the slider. That's what this does, guys. If the slider is changed, then set PathNode line of sight distance is also set. Is there anywhere else where this happens? Let's take a look. So let's look at find all references. Find all references allows us to look at all the references in the scene. So this one, PathNode line of sight distance happens right here, where it should set it for you right here. So if you miss this line, then the only way that it'll set the line of sight distance is if you click onto the IMGUI. If you miss this line right here, so that's when it's done. The other time it's set is here. That's inside of IMGUI. Here it's when it's defined. That's in the .h, and here where it's actually the function itself that changed that node. So those are the three things that are done. So I think it's okay the way it is. I don't see a problem with that at all, the way it's been done. Okay, so we're just trying to troubleshoot because you guys had some weird stuff happen, right? And so did I, actually. All right, so let's see what else happens. So we have ship position and angle. When the ship changes position, we change the, I wonder if I missed something. He might have had it and I must have missed it. So let's see if Alex had any changes. 0, 1, 1, 0. Did he change anything here? Target position, I don't think so. String label, get transform, position X and Y, position 0800. No, this looks all good. And then this is build grid. If we change our obstacle buffer, no, yeah, this is okay. So let's suppose I want to calculate the distance. Target position 0 and 800. There's the angle. And there's the slider. Now, it looks all good to me. I think the problem, if there's any problem at all, is in those check functions, these things here, these check functions, and probably check PathNode line of sight, because we're doing it so often. Check PathNode line of sight is something that we have to check out. So check PathNode line of sight. Let's check this. So the distance between the PathNode and the target, whatever the PathNode and target is, and that can be the ship or the target, whatever the target is. So start in node, and then that gives us a normalized direction. We're changing the, we're return a Boolean to check agent line of sight between the path node that we're checking and the target object. Okay, so it could be check agent line of sight in here. There could be an error in this little function here, this function that is actually a monster function. Let me just check it one more time to make sure that we don't have any issues, because that's the function that could have issues. Check agent line of sight. We're going to say goodbye now, but I wanted to make sure that you guys are good with all this. Check agent line of sight. No. No. Good. Closest edge, agent, and targets. Yeah, looks all good to me. It's something else. We'd have to go through it and check different cases to see if it's correct and see why it happens. Also, when you move an obstacle, it'll put the nodes on top of the target and spaceship. Does it? Oh yeah, because it redraws them. Yeah, and the reason why is because if you do that, and if you move the obstacles around, then notice how they go on top like this. They go on top of it because the whole grid gets redrawn, right? But what you can do is when you build grid, if you want to find this thing, when you loop through and re-add the grid back. So first of all, we clear nodes. And then when we do on add child right here, add child has some options. Add child has a layer index. So notice it says add child and then whatever the child is. And then there's a layer index, which is normally 0, right? Unless we say otherwise, right? And then there is a order index that we can also, kind of order in layer. So we can specify where this thing is going to be, right? So, and so we can say is whatever when the child is added, what about if we specified a layer index? And because layer is normally 0, which layer do we want them? We want the grid to be posted after the obstacle. So this should be 1 actually, right? That should be where it's being posted, 1. And this will always be 1 no matter what happens. Let's see how that works. And then what we can do is in the start scene. So if I go into the start function, so these are just tweaks, right? So in the start function, when you add the create obstacles from file, let's go to definition. We can specify that each of the obstacles are being added into the 0th layer if you want to be really specific, right? So that's the bottom layer. So it goes 0, 1, 2, and so on, right? And then, so these obstacles aren't going to change once they've been added, but they're going to redraw the grid. So the grid gets drawn at 1, and then what we can do is let's hop to start. So we can change these instead of the position being how it works. We toggle the grid, we turn the grid on, and then for the ship, when it gets added, we'll say that the ship is at layer 2, and the spaceship, so the target is layer 2, and the spaceship's at layer 3, and so that would stop that stuff from happening. Let's see if that works. So again, if I toggle the grid, you can see that that's cool. And now if I move anything around, we're still good. Same thing with the target. If I move the target around, and even if I move these around, nothing changes. Okay. All right, guys, that's it for me. Last thing to note for you, okay, is there's this piece for students that you've been asked to do from Alex. You must draw a path from the ship to the target using 1 or more nodes to connect them. And Alex is asking you to do that, and you should probably use some kind of button to do that as well. So what he's asking you to do right in here is when you run this thing, so what I recommend is finding the closest node. When you click on node line of sight to both target and spaceship, then find the closest node to the ship. That's what I would do for that last part to get full marks, right? Find the closest node that goes from the ship that has both line of sight, that has line of sight to both the ship and the target. Why? Because, well, this is probably the one that I want. Now, if you really wanted to, the other one that would really work is is if you wanted to say line of sight just to the spaceship, to the target. So if I click this one, you can see that clearly this is still the closest node that has line of sight with the target. This is the one you want to use, the closest node. So you draw a line from the spaceship to the closest node. You find out what the closest node is, the distance between the ship and the closest node, and then from there you can draw a straight line to the target, and that'll be okay. If you move things around, you could toggle that line on and off here in IMGUI. That's what I recommend you do. I think it's going to be a much better solution than if you draw a line once and it stays there forever. Doesn't look right. Okay, any questions around this before we go? Because I'm already late for my other class. I'm going to put this up on GitHub. So let's put the solution we have on GitHub, right? So again, I'm just going to go to, we've saved everything. I'm going to say final tweaks for lab 6. Okay, so commit to main and push to origin. And that should do everything you need. And let's get rid of that little line. My annotation is not going to clear until I clear it. Okay, any questions before we go? All right, guys. Other than that, thank you so much. And hopefully we'll see each other next week. Thank you.